last lesson we're going to look at for this week is going to finish up the appendix in the back of the book, which is on complex numbers. And now we're going to take a look at the very first part of 5.3. So we did adding and subtracting with complex numbers. We're going to finish up the multiplying and dividing today. So on the test, you could expect to see one of each. Okay, for complex numbers, you'll have an add, a subtract, a multiply, and a divide. So that'll be four questions right there on the test. All right. So we left off yesterday by saying I equals the square root of -1. And again, that is not something that you can prove. Okay, any more than I can prove to you, parallel lines don't cross. It's just one of those things that we assume it's true. We're going to start with that as a fact. Everybody agrees on it. And then from there, we can build off that to figure out something like this. Does anybody remember what we said yesterday I squared equals? Yep. It's equal to -1. And that's an important idea. So there is a power you can raise an imaginary number to, and the I part goes away, and you end up with just a real number. So the fact we can make the I go away sometimes, that's important. And anytime you're left with I squared in a problem, we would never want to leave that as the final answer. Anytime you see I squared, you have to remember to change it to -1. Okay, and that's what I just said. Where you're going to see I squared come up a lot is when we multiply and when we divide. It doesn't usually come up when you're adding or subtracting. Multiplying and dividing, absolutely. And the reason it's going to come up when we multiply and divide is because when you do a product of complex numbers, the way you do it is similar to how you learned FOIL, or some people call it a double distributive property. You have to multiply everything in the first parentheses by everything in the second. And FOIL is kind of a common word people use to remember the pattern. You multiply the first terms together, the outer terms, the inner, and it's when you multiply the last terms, that's when you're going to end up with an I squared. The last term in the first parenthesis is BI. In the second parentheses, it's DI. If you multiply those together, you're going to have an I times an I, which is I squared. Okay, so when we multiply, we'll go through one step at a time. Make sure people are with us. And notice when it's multiplication, there is no symbol between the parentheses. That means multiplication. So in math, you don't have to put a dot there for it to mean multiplication. So on the test, if you see a problem, like, I'll scroll back up in a second, like that, even if it doesn't say multiply, you know that that has to mean multiply because there's nothing between the parentheses. When there's nothing there, it means multiply. Okay? And that's the pattern that we're going to use to multiply it out. Some people call it FOIL, some people just call it the distributive property twice, whatever you want to call it. All right, let's go through it and see what happens. So, I want to multiply 2 plus I times 1 minus I. So let's start with the first two things. Okay, we're going to do 2 times 1. That's the first thing. Ben, what is that going to give me? 2. We get 2. Jaden, how about 2 times negative I?
Negative 2i?
Yeah, it's just like doing 2 times negative x. We would say negative 2x. Well, this is 2 times negative I, so it's negative 2I. All right. Don, how about 1 times I? Yep, it's just an I. And now let's look at the last part. Positive I times negative I. First of all, Raymond, what's a positive times a negative?
It's going to equal a negative.
That's going to be a negative. So let's put that down. And now I have I times I. So what's going to go after the negative, Raymond?
What is the I squared?
It's going to be I squared. I times negative I is negative I squared. Now, we have to combine like terms, and anywhere we have an I squared, we talked about what we need to change that to. So let's finish it up. So for now, we've got that 2, but we've got some like terms. Colby, what are my like terms there that I can combine?
Negative 2i and I.
Yeah, negative 2i and positive I. It's just like doing negative 2x and x. Same thing. What would you get if you add negative 2i and I?
Negative I.
Negative I. So you've got that. Still have that minus. But I don't want to put minus I squared. I want to change I squared to what we said it's equal to. What do we always change I squared to? Jaden?
Negative 1?
Always change it to a negative 1. And now, because you've got a negative from the I squared, and you already had a negative, what's going to happen when you do minus a minus here? Yep. That's going to change to a positive. Okay, so what you're really going to have is 2 minus I plus 1. Now you can finish combining your like terms, which is 2 plus 1. And the final answer is 3 minus I. You always want to put your final answer in this format. Real part, plus or minus, depends on the problem. Imaginary part. Every answer should always look just like that. In this case, because the only number in front of I is really a 1, you could write the answer like this. You could put 3 minus 1i. That's the same thing. But usually when it's a 1, we don't put it. Okay. Questions on that one? All right. Let's try this one. 8 plus I times 3 plus I. Okay. So Lacey, what's the first 2 things we'll multiply?
Isn't it 8 times 3?
All right. 8 times 3, which gives me
21.
how much?
21?
That'd be 7 times 3.
Oh, then I don't.
Yep. 24. All right. 8 times 3 gives me 24. Jacob, what's the next thing I multiply?
2i. Actually, the 8 with the I.
The 8 with the I, which is how much?
8i.
8i. So we got that. Cassidy, the next thing I multiply?
I, right?
Yep. I times the 3, which gives me how much?
3i.
3i. And the last thing is a positive I times a positive I. And Autumn, what is positive I times positive I?
I squared.
That's going to give you I squared. All right. Now, so we don't have to rewrite it a whole extra time just for that one thing. Let's put right above it what I squared is going to be. Mateo, what did we say I squared is?
You switch it to 1.
So I squared, not 1. Then what did we change it to in the last problem?
You went from, it was like minus -1.
So I squared turns into what number? -1, yeah. So let's just put that in parentheses right above it. That's really a -1. So I really have 24 plus -1. So Katrina, what's that going to give me?
Sorry, what's the question?
When I combine 24 and I squared.
Oh, 23.
23. So 23, and then Jotty, 8i plus 3i. 11i. Again, try to make sure your 1's and i's don't look the same, otherwise you're going to probably confuse yourself. Okay, so 23 plus 11i. Questions on that one?
What happens if you mix up the order? Does it matter or not?
It would matter if I specifically asked you, like on the test, what's the real part? And you said 11 because you're like, oh, that was in the front, but that would make a difference there. So you have to understand 23 is the real part and 11 is the imaginary.
Oh no, I meant that what happens if you mix up the order that you FOIL it?
Nothing, as long as you do it correctly.
Okay, that's
So you basically have to end up multiplying everything times everything.
okay.
Whatever order you want to remember to do it in. Alright, okay, so that's multiplying. So let's take a look at something we're going to need to do division. Okay, we're going to look at something called a conjugate. So let's say I had a complex number. I'm just going to name it Z. That's what I usually name complex numbers, Z. And the complex number Z has a real part to it, and it has an imaginary part. The real part is A, and the imaginary part is B. And the A and the B would be numbers if we were doing an actual problem. If I ask you to find what's called the conjugate of that complex number, you're going to see a symbol that has a horizontal line above it. That line means the conjugate. Okay, and it's pronounced Z, and there's a bar above it, so they say Z bar. That's what they call it. And it means to find the conjugate. Now let me explain to you what the conjugate is. Conjugate is very simple. If you have to find the conjugate of something, all you have to do is you leave the real part the same. You don't do anything to that. But you take the imaginary part and you make it the opposite sign. So if it started out as a plus, when you do the conjugate, it becomes a minus. If it started out as a minus, when you do the conjugate, it becomes a plus. So all you're doing is changing the sign. And a short way to say that is just negate. Negate means make it the opposite of. So you're changing the sign of the imaginary part. That's all you're doing. So what I'm going to do is I'm going to give you a table, and I'm just going to give you a complex number on the left, and on the right, I just want you to tell me the conjugate. And you'll see what we use the conjugate for in a minute. All right, so on the left, I have a complex number. The first one is 3 plus 4i. And on the right, they want me to find the conjugate of the complex number that's listed. What would be the conjugate of 3 plus 4i?
3 minus 4.
It would be 3 minus 4i. So that's the conjugate. How about -8 minus 2i? What would be the conjugate of that? About, Tom, what would be the conjugate of negative 8 minus 2i?
Negative 8 plus 2i.
Negative 8 plus 2i. All right. How about the conjugate of 5i? Ava, what would be the conjugate of 5i?
Would it be 5 divided by 5? Or negative 5? I don't know.
Not sure. Anyone help her out? Well, what's the real part in that number?
5?
That's the imaginary part.
Oh. Then I don't know.
James, what's the real part? 0. So if it's confusing because it doesn't look like everything else, think of it that way. It's 0 plus 5i. So what's the conjugate of 0 plus 5i? Yep. James?
0 minus 5i.
0 minus 5i. Because the 0, we don't need to write something when it's 0. All we do is say minus 5i. So 5i, the conjugate is negative 5i. How about 3? What would be the conjugate of that? James?
Does that just say 3?
Why not negative 3?
Because there's no I after it.
There's no I after it. If you're like, well, wait, what? What's happening there? Think of it like this. This is 3 plus 0 imaginaries. The conjugate is 3 minus 0 imaginaries. Well, plus 0 minus 0 is the same thing. So that's why that one stays the same. So, any questions on if I give you a number, how you find the conjugate of it? All right. Now, let's see what happens when we do another multiplication problem, but we're going to multiply a number by its conjugate. So we're not just going to do any random problem. We're going to do a number times its conjugate. So they gave me the number 3 minus 4i. Ben, what's going to be the conjugate of that? Okay, how do you find the conjugate? No, we don't multiply to find the conjugate. We just have to change one thing. And I think we already did this one in the table up above, I think. All right, if you're not sure, you should probably write it down. Yeah. Yeah.
Wouldn't it just be 3 plus 4i?
Yeah. It's actually the first problem we did in the table. 3 plus 4i and 3 minus 4i are conjugates. So, what they basically want me to do here is take this and multiply it by that. Multiplying conjugates together. Now I can quickly look at that and already tell you the answer. It's going to be 25. So there's a way I was able to do that very quickly in my head. Let's just spoil it out, do it the long way, and then I'll show you the pattern to be able to do a problem like that in your head. Unfortunately, the shortcut only works if you're multiplying conjugates. It doesn't work if you're multiplying just random numbers, right? So let's take a look at what happens. What's 3 times 3? Yep, you get 9. What's 3 times 4i? 12i. What's 3 times negative 4i? Okay.
Negative 12i.
Good. Negative 12i. Positive 12i, negative 12i. Those are going to cancel out. Whenever you're multiplying conjugates together, you don't ever need to worry about doing the O and the I because they're going to cancel out every time with conjugates. So, those are gone. We did the first. 3 times 3 is 9. Now let's just do the last. Negative 4i times positive 4i. Tom, what's that going to give me? Negative 4i times positive 4i.
Negative 69.
Close. Forgot one thing.
Oh, negative 69 squared.
Negative 16i squared. Okay, so we got 3 times 3 is 9. The outer and the inner canceled. Negative 4i times positive 4i is negative 16i squared. And Raymond, negative 16i squared, we can change that I squared to what number? We can change that to negative 1. So what we really have is, remember, these are all gone. 9 minus 16 times negative 1. Well, 16 times negative 1 is negative 16. I just multiplied 16 times negative 1, put the answer right there. What's 9 minus 16? Yeah. 25. And that's what I said the answer was going to be right away. Yeah.
How did you get that 10i squared?
So we had, I'm sorry, where do you see 10i squared? Sorry.
Oh, thank you.
Yeah, that's a minus 16. That came from the negative 4 times the positive 4. So let's look at the shortcut to kind of do this in your head. If you want to multiply conjugates together, all you have to do is look at the first number that they give you, which is 3, and square it. Look at the second number that they give you, which is 4. Square it. And if you're thinking, well, wait, should I use the negative 4? Should the negative go with it? It doesn't matter. You're going to square it. Negatives go away when you square them. So just take the first number, square it. Take the second number that they give you right there, square it. When you add them up, that's the answer. If that shortcut is confusing, then FOIL it out every time. But you're going to be doing a lot of arithmetic that's just going to cancel out. In fact, half of what you do when you FOIL is pointless when you're multiplying conjugates. All right, let's try this one. Using the shortcut. So what would be the first number that I would square here? Yeah?
Would you multiply the 5 with 5?
So we're going to use the shortcut. We're not actually going to FOIL it. So you take this number and do what with it? Just square it. Okay? What's the next number we're going to look at? Yep. 4. And what are we going to do with that? Square it. Add them up. Done. That's the answer to the whole problem. 41. Okay, again, if you want to FOIL it out each time, 5 times 5, 5 times 4, you can, but you're going to end up with 41. So when we have to do multiplying conjugates together, I'm going to use the shortcut because it's quicker. Okay. Any question on the on that shortcut? All right. So now we know what conjugates are. We know what happens when we multiply conjugates. Here we got 41. Here we got 25. What kind of answer does it look like you get when you multiply conjugates together? Yeah. It will always be positive, yes. And can you be more specific? Yeah. Odd? Will it always be odd? That's a number theory question I'd have to think about. When you square a number and add them together, could it ever come out even? Yes, it could. If you had the 2 squared, it's 4, and 2 squared again is 4. I think you could end up with an even. So it might not always be odd. But it will always be, yeah?
A real number?
It will always be a real number. Whenever you multiply conjugates together, the I disappears from the problem. And that's important. We need a way to make i's disappear when we do division. Now we have it. Multiplying by a conjugate makes the I disappear. Yes?
No. I was gonna ask if it always be a whole number.
Yeah, it will never be, unless you started with things that weren't decimals. But if you start with numbers that don't have decimals, you're gonna end with numbers that
Are
don't
you
have
gonna
decimals.
give us like any questions that are with decimals for these?
Uh, The answer might come out to something with a decimal, but I don't think the original problem will have a decimal. And you'll see what I mean by that, I think, on the next example.
Okay.
Either the next one or the next one. Let's see. Okay. So, why do we use the conjugate? The conjugate is useful when you want to divide two complex numbers. Because when you have a complex number, you're not allowed to leave an I in the denominator. You need to be able to get rid of it. How are you going to get rid of an I? Well, you can multiply a fraction by anything you want, as long as you do the same thing in the top and in the bottom. We have something special we can multiply by that would make the i's cancel out. Okay, so we'll go back and do that problem in a minute. We'll start out with the easier one. But the way you divide two complex numbers is you actually multiply. You don't actually do division. Okay. To divide two complex numbers, you multiply the top and the bottom of your complex number by the conjugate of what's in the denominator. And really the whole point of doing that is to make the I in the bottom go away. So divide two complex numbers, figure out the conjugate of the denominator, and multiply the top and the bottom by the conjugate of what's in the bottom. So here's an example that there are no decimals in this original problem. Right? You have a 1, a 3, and a 4. But when you write the final answer will be a fraction. Okay? It will have a decimal in it. But I'm not going to change it to a decimal if I have a problem. I usually leave it as a fraction. All right, so let's divide 1 by 3 plus 4i. We can't leave the 3 plus 4i in the bottom. So what can I multiply by? I have to do the same thing in the top and the bottom that will make this I disappear. Yep.
3 minus 4i.
3 minus 4i. And 3 minus 4i. All right. So in the bottom, we already know what happens. I think we did this problem earlier. What was 3 plus 4i times 3 minus 4i? Yeah.
Was that 25?
That was 25. Okay, we already did that. Square the 3, you get 9. Square the 4, you get 16. Add them up and you get 25. Now the top this time is actually pretty easy because that is a distributive property, but you're only distributing a 1, so nothing is going to happen in the top. Usually it's not a 1, okay, but this time it was. So in the top, we get 3 minus 4i. Now, that is not standard form. Remember, I told you your answer should always look like this. So to make that look like this is how you do it. You take each number in the top and put them over the 25 separate. So the real part is 3 over 25, and the imaginary part is a negative 4 over 25, and they usually put the I right next to it, just like that. So 3/25 minus 4/25, and that's what I mean about your answer could have a decimal in it. But I am not going to find the decimal. I'm going to leave it as a fraction, and I'm going to do that on the test as well. Yeah.
If you left the I with the 4, would that just be incorrect, or?
No, you could do something like this. Most people don't write it that way, but that is not incorrect. The reason they put the I next to it is kind of the same reason, like if you're doing an equation in slope-intercept form, let's say you had y equals 1/2 x plus 3. Most people write it this way. That's your slope, that's your intercept. They just put the letter right in the middle of the fraction. You wouldn't be wrong if you did this. That's not normally how we teach that in Algebra 1, but you could do it. And it would be the same exact thing that you just mentioned right there. Okay, any other questions on that one? All right. So let's look at, I think we have one more. Divide. Okay. So Colby, what would I multiply top and bottom by in this?
Conjugate?
Yep, which would be?
1 minus 4. Or would it be 5 plus 12 by 4?
Yeah, remember it's the conjugate of what's in the denominator. Okay, so we want to go with the 5 plus 12i. And the bottom, that's going to be pretty quick to do. What's 5 squared? 25. What's 12 squared?
144.
144. What's 25 and 144?
169.
169. Bottom is done. Now, unfortunately, in the top, you can't use that trick because you're not multiplying conjugates. You just got to FOIL the whole thing out. So we're going to get 5. But let's see if when we FOIL, we can combine the imaginaries at the same time. 1 times 12i gives me how much? 12i. What's 5 times 4i? So what's a 12i plus 20i? That's 32i. And then we're going to have positive 4i times positive 12i. What's 4i times 12i? James?
48.
Careful, we forgot something. Yep. 48i squared. And Jody, 48i squared is really what number? That's really a negative 48, because that means 48 times negative 1. So in the top, I'm going to have 5 take away 48. That's negative 43. Plus 32i over 169. Okay, the last thing, which I probably would have done as I wrote that answer, is just to split it into 2 fractions. Negative 43 over 169 plus 32 over 169. That's how you'd see the answer on the test. Questions on that? All right, so that finishes up the A4 part. And the last thing we're going to do is look at 2 things in 5.3. The first one is very, very simple. So we've talked about complex numbers, written like that. 2 plus 3i. Well, we can graph that number. And it's pretty much exactly like graphing this number. The difference is we're using what's called the complex plane. So when we graph complex numbers, we rename the 2 axes. We rename the horizontal axis the reals, and the vertical is the imaginary. But if you think about 2 plus 3i as 2 comma 3, it's going to basically look exactly the same. So let's look at 2 plus 3i. What's the real part of 2 plus 3i? Yep. 2, and that's a positive 2. Just like with an x-axis, positive is right, negative is left. So this means to go 2 units on the real axis. 1, 2. 1, 2. Now, the imaginary part is, Mateo, what's the imaginary part?
Plus 3i.
Plus just the number.
Oh, 3.
Just the plus 3. So the imaginary part is a plus 3. Plus means to go up, minus means to go down. So you're going to go to 2 on the real axis, positive 3 on the imaginary axis. 2, 3, put a dot, and that's how you graph the point 2 plus 3i. How about this one? 4 minus 8i. Anybody tell me, just from the origin, which way do I go to graph 4 minus 8i? Yep.
You have to write 4 times and graph 8.
I'm going to go right 4, so I want to go to 4 on the real, and I want to go to negative 8 on the imaginary. 1, 2, 3, 4, 5, 6, 7, 8. It's 4 minus 8i. Right? How about negative 8? How would I graph that one? Yeah, Jade?
Would you be going left 8 on R and then not moving anywhere on I?
Yeah. So we're just going to go left 8. Think of it as negative 8 plus 0i. There is no imaginary part. So that's right on the axis. And how about 5i? How would I graph that one? Yep. Jane?
Move up 5.
Up 5. There's no real part. So you're not having any left or right movement. It's just up 5. The biggest mistake people make with that is they switch the axes. You can't switch them. The real has to be the horizontal, and the imaginary has to be the vertical. Always. Okay, so any question on that? All right, so last thing. And this is where we would start to see the connection between what we were doing on Monday, which was writing, and Tuesday, writing coordinates in polar, and what we learned in the back of the book, which was on complex numbers. We're not going to fully get to see the connection because we're not spending the 4th day on the material, but we'll start to kind of see a little bit. So let's say that we have a complex number like that. I know I normally use the letters A and B to represent a complex number, like A was the real part, B was the imaginary. I switched to using an X and a Y because now we're thinking about graphing. And I want you to remember X represents horizontal. Most people will remember that better than A. X is horizontal. And Y represents the vertical. Also, I know I normally put the I after, like that. Well, I'm putting the I before it because that's how your book does what we're going to do next. So if you look something up in your book, you're going to see what I'm doing and it'll match. All right, but that's just a complex number with a real part and an imaginary part. That's called rectangular form. Because when you try to graph something like that, you graph it on a grid that looks like squares or rectangles. And that's another reason why I use those 2 letters. If you remember when we changed from rectangular to polar, I would do something like this. Rectangular, polar, and I would put the 2 letters above it. And I always used an X and a Y when I wrote rectangular form. What were the 2 letters that I used in polar form? Yep. I used an R and a theta. We're going to have to figure out what the R and what the theta is for that point. It's exactly the same formulas that we learned earlier in the week. There is no difference. If I wanted to say convert 2 plus 3i to polar, pretend like that point is on a circle. To convert it to polar, you need to figure out 2 things. What's the distance to the origin? And then if you made a triangle out of it, what's the angle right there? It would basically be the exact same way you would convert this to polar. You can change this to polar. You can change that to polar. It's the same thing. The answer looks a little bit different because it's imaginary, but we'll go through how the answer looks right now. So, remember, in polar, you don't want that, and you don't want that. What you do want is an R and a theta. Does anyone remember from Monday, what was the formula we used that started out x equals, and then it had an R, a trig function, and theta on the other side? Yeah?
Was that x equals r times cosine?
Yeah, it was x equals r cosine theta. So what we're going to do is replace x with the formula we have for Monday. And what about y? Anybody remember what was the formula we had for y? Yep.
Y equals r sine theta.
R sine theta. So to get rid of the y in this formula, we're going to get rid of it the same way we did on Monday. So I'm going to replace x. I already wrote it down up above, so I'm not going to write it again. I'll just put the recall up here. So x is r cosine theta, y is r sine theta. Did I already write it? Nope, let me plug that in. So I have r cosine theta, that's the x, plus I times, now we're not going to put y, we're going to put what y is equal to, r sine theta. And what letter do both of these terms have in common? The two parts I just underlined. They both have R. And whenever you have the same thing common to two different things, you can factor that out, so you only have to write it once. So let's put the R in front. And if you take R out of this part, what would be left? Cosine theta. And what if you take R out of that part?
Sine theta.
And what else? The I, right? You'd be left with an I and a sine theta. And that is how you write a complex number in polar. You don't do that out. You leave your answer just like that. That's called the polar, you don't have to write it twice, but that's called the polar form of a complex number. How do you get R? Well, use Pythagorean theorem. That's the R squared equals x squared plus y squared. How do you get theta? That's the inverse tangent of y over x. If you're in quadrants 2 or 3, what did we say you have to add to the angle? Only if you're in quadrants 2 or 3. Yes?
Pi.
You have to add pi if you're going to do it in radians, or what if you're doing it in degrees?
180.
180. So the formulas to find the r and the theta are exactly the same as the formulas you used last night. So here's what a final answer would look like. 2 cosine, I'm just making this up, 30 degrees plus I sine 30 degrees. That's a final answer to a problem. You don't actually plug in cosine 30 on your calculator and sine 30 and then distribute the 2. If you do this out, you're going to be changing it out of polar form, and you're going to be changing it back to what you started with. So you leave it just like that. All right, and we'll try one example of that, and that'll be it. So I want us to write that complex number in polar. Now, just to be clear on that, what number is in front of I, even though it's not written in this case? Ava?
0. zero?
Well, if it was a 0, then you would see it like that.
Oh, one.
Yeah, there's really a 1 there, right? So we can just, if you want to put that in, because it helps you to think, okay, the imaginary part is -1, you can. All right, let's start out by finding our radius. Okay, Jacob, what's the real part here?
The 3, the square root of 3.
Square root of 3. So remember, this is the formula I'm using. I didn't write it down again because you already have it in your notes. R squared equals x squared plus y squared. Right. There's my x plus, James, what's my y in this case? -1. Remember, the y is what's next to the I. It's not the I at all. It's what's next to it. What's next to it? -1. All right, so when you square square root of 3, you get 3. When you square -1, you get 1. So Cassidy, what's my radius going to be in this problem?
4.
Good. Well, radius squared would be 4. So what's my radius?
16. Wait. 2.
2. There's my radius. All right. Now, let's find our angle. What quadrant is this going to be in? Positive x, negative y. Where are we going to be? Yep. 4. Do I need to add 180 when I'm in quadrant 4? No. So it's just inverse tangent of, and can somebody tell me what my fraction is going to be? Ben?
-1 over the square root of 3.
Good. -1 over the square root of 3. Perfect. Now let's just type that in and see what we get. And if you're looking at it like, wait, you said don't ever leave square roots in the bottom of a fraction. You mentioned that, a while ago. Well, I'm not leaving it there because that's not my final answer. Okay, that's just what I'm going to plug in. So it's fine to plug that in, just the way it is. So square root of 3, and you get an answer of -30 degrees. Now, what would that be the same as if they wrote it as a positive angle? Think about what you could add to it. Most of these answers, they're going to make them positive. Yep.
Would it be 330?
That would be the same as 330. Okay, so there's the angle. There's the radius. Final answer is going to look exactly like what's in that box. Just fill in the number we have for r, fill in the number we have for theta, and stop. Final answer. R, parenthesis, cosine 330 plus I sine 330. So at this point, it's actually a little bit less work than what we did before, because when we did this yesterday, we always had to do out the cosine and the sine and get the decimal. You don't have to do that out today. You leave it just like that. And that's how you write a complex number in polar. All right, so we've got just under 15 minutes. So I think what I'll do is I'll put the homework up. I should have enough time to get the topics for the test on the board, so you can see what they are by the end of class. Yes.
Can you just scroll up for a second?
I'll put the homework up, and while you guys are copying that down, I will put a list of topics. So the first part of the homework, that's on multiplying and dividing complex numbers. And the second part of the homework looks at graphing complex numbers the way we did. and then converting complex numbers into polar.